Hi guys, this is section 9.4, rotation of axes. The first thing that we're going to learn how to do in this lesson is to be able to identify the conic sections without having to go to all the trouble and work of completing the square. So we first just need to make sure that it's in this form here. This is the non-degenerate conic section. All that really means is that we have a conic section, but we haven't identified yet what it is. In order for this to work, A and C cannot both equal 0. A can equal 0 or C could equal 0, but they cannot both equal 0. As long as that is the case, we can go ahead and use this formula. All this formula means is that our equation has either an x squared or a y squared or both, and the letters A, C, D, E, and F just represent, well, F, not F, A, C, D, and E represent the coefficients, and F represents the constant. So, for example, if A was 0, this equation simply just would not have an x squared in it. Or if C was 0, it would not have a y squared in it. If A and C were both 0, we would just have a line, and it's not that difficult to identify a line. So as long as A and C are not both 0, we can go ahead and work with this. If A and C are the same thing, then we have a circle. If A times C equals 0, then we have a parabola. That means either A is 0 or C is 0. We would most likely see this in an equation that was missing either x squared or y squared. Then we would know we had a parabola. If A and C are both positive or both negative, in other words, if we multiply them and get a positive number that is greater than 0, then we have an ellipse. So if A times C is positive, or if A times C is greater than 0, however you prefer to word that, then we have an ellipse. If A times C is less than 0, that means one of them was negative, and we end up with a negative product, then we have a hyperbola. Notice how on example 1, all of these are in the non-degenerate form. So we really just have to identify our A and our C. So in A, problem A, we have A equals 4 and C equals negative 25. They do not equal each other, so we do not have a circle. One is positive, the other is negative. This means when we multiply them, we're going to get something that's less than 0, right? We end up with negative 100, which is less than 0. So this means that we have a hyperbola. Sorry for my writing on this. I'm still getting used to this. All right, for B, we have an x squared, we have a y squared. We don't see coefficients, so we know that their coefficients are 1. So if A equals 1 and C equals 1, that means that A equals C. And as long as they are both not 0, then that means we have a circle. For C, we have no x squareds at all. So that means that A equals 0. And since y squared does not have a coefficient, we know that C is 1. A times C is 0, so we have a parabola. And then finally, on D, we have that A equals 9, C equals 25. This is a positive number, so we know that it's greater than 0. So here we have an ellipse. Go ahead and do checkpoint 1, pause this video, do checkpoint 1, and then come back for what's next. You may pause here to check your answers for checkpoint 1. If you made any mistakes, please go back and see if you can figure out why, and then come back for the next example. Next, we learn about the rotation of axes. What this means is if we had our axes like this, they could be rotated like maybe, I don't know, 45 degrees or however many specific degrees, and the same set of axes would look like this, only this is after the rotation. You may remember from geometry and algebra 2, whenever we transformed things, we'd give the x and the y of the coordinates tick marks to indicate that there was a transformation. So you'll see those tick marks here in our formula. I'm going to call them prime. So, for example, this first formula would be read that x equals x prime cosine y minus y prime sine y. All we do with these formulas is we will plug in things that we're looking for. So, for example, on example 2, it says that we are given the equation that x, y equals 1, and it wants us to find the transformed coordinates after we rotate the axis 45 degrees. So if we're rotating 45 degrees, that means that theta equals 45 degrees. All we do here is plug things in. So we're going to take x times y equals 1. And so we look up to our formula, and we know that x is x prime cosine of theta, which we know is 45 degrees, minus y prime sine of theta. That's our x, and then our y is x prime sine of theta plus y prime cosine of theta. And according to our original equation, this equals 1. Well, the cosine of 45 is rad 2 over 2, and the sine of the sine of 45 degrees is also rad 2 over 2. So this is x prime rad 2 over 2 minus y prime rad 2 over 2 times x prime, rad 2 over 2 plus y prime rad 2 over 2 equals 1. So notice we have a factor, we have two exact factors. The only difference is the minus and the plus. So you might remember from Algebra 2 that if we multiplied these together, we'd get the first term squared minus the second term squared, and there would be no middle term for this because they would cancel each other out. So if we do that, we're going to go ahead and square our first term. So that gives us, I'm going to have the coefficient come first because I'm going to do something with that. So rad 2 over 2 squared becomes 2 over 4, or simply 1/2. X prime squared is x prime squared, making sure that that doesn't look like x to the 12th. It is very difficult to write with the stylus. And then minus the second term squared. So that's also going to be 1/2 y prime squared equals 1. Now we're happy about this equals 1 right here because that is the standard form of the equation we're looking for. So we can just go ahead and simplify what we have to be x prime squared over 2 minus y prime squared over 2 equals 1. And we can tell by looking at this equation that we have a hyperbola. You might remember from all of our practice with hyperbolas that y equals positive or negative b over a times x. So in this case, we would end up with the square root of 2 over the square root of 2, which simplifies to 1. So ultimately, our graph is y prime equals our plus or minus x prime. So when we go to graph this, this would be our normal axes, but we want to rotate 45 degrees. So our new axes are really here. Our vertex is still going to be at the square root of 2, 0, only instead of being on this axis, it would be on this one. So we'll have one here, and then we'll have one at the negative, and then our hyperbola is going to look about like this. Go ahead and try checkpoint 2, and then come back to my next video for the rest of the lesson. Here is the answer to checkpoint 2. This is your equation and your graph. Please click on my next video for the rest of this lesson.